Awesome. Hi, I'm Michelle. I work at Deloitte UK in the risk analytics function and the artificial intelligence solutions team. And given the rapid adoption of AI for all areas of business in driving value and efficiencies, the governance in controlling and mitigating the risks associated with deploying AI has largely been overlooked. And few data science teams have structured controls and testing procedures in place to in their development process. So after all, no one wants to be seen as hindering innovation and experimentation. But these AI solutions create new kinds of issues and challenges for business owners. So the self-learning nature of these tools require a more dynamic solution for controls. And the complexity of some of these tools makes it much more difficult for non-technical business leaders to really understand what is happening in these machines. So Deloitte has an end-to-end risk taxonomy where we find risks associated with adoption of AI that are wide-reaching across the organization, from people risk to supplier risk to tech risk to technology risk. So for example, how do we handle licensing issues with open source tools? And how do we make sure that our AI tools are GDPR compliant? So one of the thoughts that occurred to me recently was, if a customer wants his data to be deleted from our system, citing his right to erasure under GDPR, what happens to the models that are trained on his data set? So since we're a more technical audience, we're going to focus this talk primarily on the model risks and the technical risks associated with designing and deploying AI solutions throughout businesses. So for example, how do we make sure that our algorithms, especially ones that impact people's lives, like credit risk algorithms, are not biased? So not sufficiently considering all of these risks can result in some embarrassing public scrutiny. So some of them are related to public perception of infringement on their privacy. Others can involve more kind of legal risks, which can have financial consequences as well as reputational risks. And others involve bias in the training data or bias in the feedback mechanism, whether it can be malicious or unintentional. And AI is more and more being used to automate decision-making processes that really impact people's lives. And that includes earning and maintaining a job, getting out on bail, sentencing algorithms, and even obtaining a security clearance or securing a loan. So what are some of the risks that are involved in building an AI solution? So I've categorized these in bias, feedback inaccuracy, and misuse. So we'll go over each of these in more detail. So in addition to working at Deloitte, I've been working with a pro bono data science charity called DataKind. And one of our projects back in the US was working with a foundation to build a predictive model to figure out which criminals are most likely to reoffend. There are a lot of issues in building these models, but the goal was to target the rehabilitation services to people who are more high risk. And there are three ways the predictions could be biased. The first is the data itself reflects the intrinsic human bias. For example, if people from certain backgrounds, the minorities, the people from low-income backgrounds are found guilty more often, the model is just going to reinforce this. And the second is the selection bias. So due to predictive policing or targeted policing, if police are around more often in low-income, high-minority neighborhoods, then we are missing the data sets from neighborhoods that they didn't patrol, where a crime may have occurred. And the third, which is a bit trickier, is the uncertainty bias. So if a person in the data set has a set of demographic characteristics that are very rare, the model you build might be more risk-averse and would prefer not to make decisions about that person just because it has less information about it. So if we're building a credit risk model and you have very little information about this particular type of person, then it could be more risk averse and it would be more likely to deny that loan than accept it. So often data scientists exclude variables that can be associated with protected characteristics. They'll exclude race, they'll exclude age, often even home address. But this often isn't enough because the characteristics inside your machine learning model can reflect some of these protected classes just by the combination of them. For example, age at the time of first arrest, your education level, and the type of crime you committed can be a good indicator for some of the protected characteristics. So like a recent investigation by ProPublica found that an algorithm that was being used for recidivism to decide whether or not someone gets out on parole was racially biased. And another obvious example of an algorithm that can really affect people's lives is in financial inclusion, is in getting a loan approved. And historically, people have used the types of variables and types of data that are directly associated with your ability to repay. So your loan-to-income ratio and your credit history and your payment histories. But more and more companies are using these big data analytics techniques on non-traditional data sets. So Zest Finance and Baidu are now using Chinese internet browsing histories to determine their credit scores. And this raises a lot more of the risk of having the bias and having an impact of biased algorithms. And traditionally, a lot of the liability lay in the intention to discriminate against protected classes of people. But more and more governments are focusing aggressively on impact rather than intent. And so an algorithm that inadvertently disadvantages a protected class can face expensive and embarrassing fair lending claims, as well as reputational risk. Yeah, so next one is feedback. So because the AI solutions dynamically learn from incoming data, it's important to monitor what is coming into the model. So the first, there can be the malicious twisting of data. We all know the famous or infamous Microsoft Tay chatbot story. So there was an AI bot, Yandex, which is Russia's Google rival, that released a chatbot with a content log that activated whenever someone was speaking about a sensitive topic. But the control is quite weak, so you could circumvent it by using synonyms instead of the specific keywords that were detected. And then the chatbot ended up advocating for Stalin and advocating for spousal abuse. So the controls and design around AI tool have to ensure that it's resistant to any sort of malicious attacks. Secondly, and I think more importantly, when designing an AI tool, you have to be considerate of the impact it'll have on your actual data. So for example, the recidivism tool that I designed was for targeted rehabilitation purposes. But very similar algorithms are being used to determine whether or not someone's let out on bail. But if that person is denied bail because the model decided it was too risky and he might commit a violent crime while released, then we will never be able to figure out the counterfactual what would have happened if he had been released. So the model gets stuck in time where it's churning out these predictions without accounting for the counterfactual. So there are cases, more often cases in which AI solutions are misused by business users, and often it's because they don't fully understand the assumptions and limitations of the model. But there are scenarios in which algorithms developed with the best of intentions can be used for nefarious purposes. So, for example, the Stanford University tool that was developed that showed a model, an AI algorithm could predict homosexuality with over 80% accuracy, was criticized by LGBT organizations as being very dangerous. The professor leading the study said a driving force behind the study was to expose potentially dangerous applications of AI, and push for privacy safeguards and regulations. But we can imagine this kinds of algorithms can be used to support a regime's efforts in targeting and identifying people based on their sexual orientation. And University of Washington created an AI tool to create very realistic videos of synthetic speeches by Obama. This can reduce public trust in media sources to even lower than they are right now. And whenever possible, use of these kinds of AI solutions by third parties should be restricted and enforced through legally binding contracts. So algorithms are not inherently unbiased, and this is something that we have to stress to the business stakeholders over and over again. So systemic biases in the data has to be accounted for and actively corrected, and if it's impossible to correct, then the business stakeholders have to be aware of the limitations and the consequences. The three key principles that I proposed last year at QCon was an algorithm has to be accurate, transparent, and interpretable. And accuracy can seem obvious. After all, we're all data scientists. We try to focus on the model's performance. But a success metric, when you are trying to define it, cannot be so straightforward sometimes. So I gave a panel on chatbot yesterday, and a chatbot's success can be accounted by its intent prediction, obviously, but also customer satisfaction, gaining efficiency, how a persona reflects your company's values, core values, and the strategic initiatives. And for example, a financial or pricing model, its accuracy can be assessed by how much the model produces consistent results, even in cases of fluctuation or extreme input. And the use of the black box algorithms makes it much more difficult to identify when things go wrong, but also who's liable if it does go wrong. And there are some efforts, mostly in academia, but also to a limited extent in industry, to figure out ways to make algorithms that we use more transparent. So a Google project nicknamed Glassbox is trying to find methods to smooth out influence of outliers in its models. And Capital One is researching explainable AI. Researchers at Carnegie Mellon University are developing a method called quantitative input influence to detect the potential of bias in black box algorithms. And researchers from MIT are finding new ways to train neural network models to not only produce the predictions, but also explain and justify their predictions. And so we've only covered these algorithmic risks, but as we discussed in the beginning, this is only a small subset of risks that are introduced by designing, building, and deploying AI in business. And at Deloitte, we've built an end-to-end enterprise risk framework with associated controls, and we're working on the testing procedures and best practices with each risk. So beyond the model risks, here were some of the key themes that we discussed within Deloitte. So there's increasing scrutiny from the public and also from regulators on how AI might impact not only the customers, but also society. A lot of the AI failure news stories that we saw highlight the need for engagement with multiple stakeholders across organization. So the AI programmers and the data scientists can't be isolated anymore. They have to talk to each other. They have to talk to legal. They have to talk to the business strategy stakeholders. And this is particularly true because data scientists often focus on models' accuracy and building the best possible model, but this may not always align to the entirety of the company's strategic goals. And AI functions often adopt an agile development methodology. But data scientists should have a more structured approach to testing for potential risk prior to deployment and embed these testing processes in the continuous workflow. And finally, because AI is self-learning, the risks are also dynamic, and continuous monitoring is more important than ever. So overall, there's a strong need for organizations to be more proactive about the risks and more conscious of the risk posed by designing and deploying AI within their organizations. And with proper policies and control procedures, these risks can be controlled, especially with more engagement with the rest of the organizations about the AI strategy. But as the enterprise risk framework has changed so far with the introduction of new technologies and robotic process automations, it is time for now the enterprise risk framework to adapt to these new changes introduced by AI. I have 4 minutes for questions. Okay. Any questions?
Just raise your hand, we'll give you a microphone. Hello, and
Hi.
thank you very much for the talk, for the, I think, or I believe, is a really important aspect which you described here. And my question is about, this is a really nice approach that you have there for your company, and you're working with a lot of other big companies and clients, and I would like to know, how is your experience? So is this approach taken by a few of your clients? Are you consulting them to go this way in certain projects? So what is your experience until now?
Yeah, I think, I mean, I presented it more coherently, but this whole framework is pretty recently developed, even within Deloitte, but we're bringing it out to clients, and clients are contacting us because they're interested. But also, we started building this because as an AI solutions developer, like for chatbots, et cetera, I felt the need that we had to be more robust and be more structured about how we test the algorithm. So to have a checklist of, did you do this test, did you do that test, and like have more of the guidelines laid out for our own data scientists. But there's definitely increasing like demand from our clients for something like this, and we're seeing a lot of that demand coming from financial services industries, mostly because they're the ones that have adopted a lot of the AI, have a lot of personal data, and have more scrutiny by the regulators. But yeah, we're trying to implement it both internally and bring it also out to clients.
Okay, we have time for one more question.
Do you think such regulations should be enforced legally as well? I personally think they should be.
To be enforced, sorry?
Enforced legally. Should the government enforce machine learning engineers and AI engineers to actually consider all these risks that you discussed when they produce their algorithms?
Yeah, I mean, there was a GDPR panel yesterday that discussed a little bit about, does GDPR go far enough to protect customers from these risks or not? And it was kind of divided. Some people said, like, yes, no, it doesn't go far enough, and some people said in certain aspects it goes too far. But I think all governments, like US and EU, are going towards being more conscious about and regulating more of these kinds of algorithms that might have negative impact on the customers. And I think that'll probably especially be true for like credit risk models, for example.